Hello, it's Mr. Sarisa, and I want to turn some parametric equations into rectangular form. Once again, this time it's going to be a little trickier. So I'm going to start with x equaling, x equals 4 cosine t, and I'm going to have my y equal 4 sine t, and our t, well, we'll talk about that in a little bit. But the t could go from negative infinity to infinity. Okay? So what I'm going to do, though, first thing is turn this into a rectangular form. I notice I can't solve for t and just plug it in. If you think about what would have to happen there, we'll have an inverse sine of the y over 4 going in there, so it'd be really complicated, 4 cosine sine, inverse sine, etc. So what I'm going to do is divide both sides by 4 and have now cosine t equaling x over 4 and sine t equaling y over 4. And then remember the Pythagorean identity, where if we take cosine squared of theta and add it to sine squared of theta, that's going to equal 1. So that's what's happening right here. I'm going to take, instead of cosine of theta, I'm going to have cosine of t. And so if that's the case, then I can replace the cosine t with x over 4. And so I think a lot of times people forget that cosine squared t and sine squared t really just mean take the cosine of t and square it. And so I'll take x over 4 squared plus y over 4 squared, that equals 1. And then if I multiply both sides by 16, right, because 4 squared is 16, I'll get x squared plus y squared equals 16. And so what does that equation look like? If I gave you just x squared plus y squared equals 16, what would you say? And so hopefully you just said circle, and the circle has a radius of 4 because that 16 is r squared. And so if you go ahead and just graph that, you go onto your calculator and you graph it just like how we did before, you'll probably just see that this is almost a circle, like you said, right? It starts from way down here and goes around, but then it stops. And that's the reason. That's because we have it now set from -2 to 2 from our last problem. If you've changed that, then that's fine. But what should we do if we want to go and complete a full circle? What should we use as our interval? If you said 0 to 2 pi, then you'd be correct. So 0 to 2 pi, if you want to draw it exactly once. So go ahead in your window, change that to 0 to 2 pi, and see if that completes a full circle. And tell me, where does it start? And where does it end when you graph that? And it's just like the unit circle, right? When it started here, it started at 0 degrees and went around and finished at 2 pi degrees. Or 2 pi radians. And so that's if your graphing calculator is in radians, of course. But that's what you would see, and that's what you would expect to see. And so this will lead to certain things. You'll notice that it all went counterclockwise when you set this up. But you could draw half a circle, or you could draw like the circle 3 times, just depending on how you change your interval. So that's always going to be something that you're looking for, is your interval is another piece to this that we've never had to deal with before. Okay, I hope that this helped. Thanks.